Power Flow Podcast, amplifying diverse voices in the energy revolution. Here's your host, Amy Simpkins.
Welcome back to the Power Flow Podcast. I'm your host, Amy Simpkins. On today's episode, I have my friend and colleague, Zora Chung from ReJoule. Zora is the co-founder and CFO at ReJoule, a battery diagnostics and optimization startup with a mission to reduce battery waste and enable the circular economy for batteries. Before founding ReJoule in 2017, she spent 13 years in corporate finance at Clorox and Walmart e-commerce. She's created long-range strategic and financial plans, negotiated contracts, and evaluated new and existing business models and optimized them for scalable growth. At ReJoule, she manages all things non-technical and has helped ReJoule secure almost $5 million in non-dilutive grants. Their biggest grant is a $3 million project funded by the California Energy Commission to repurpose used electric vehicle batteries in a second life application. Zora, welcome to the show.
Thank you, Amy. It's great to be here.
I'm so thrilled to talk to you. This conversation, I mean, all the things that I have heard about ReJoule, are feeding a need that I have known was out there and I didn't know anyone was addressing. So meeting you and meeting, ReJoule has been an incredible thing. And I am so excited to learn more about the circular economy for batteries. And I'm just going to, before I jump in with you, I'm going to tell you kind of from my perspective, working on batteries that go into behind the meter microgrids, which I know is a little bit different, but maybe sort of adjacent to the EV batteries. When we do modeling of those behind the meter batteries, people ask us about end of life. People ask us well, what happens? And we certainly build into the model, battery degradation over the years. We build in some module supplementation because we assume you're going to need to bring in more capacity. But beyond that, and we're very honest, we're the battery industry is just so nascent. And so I'm really excited to hear more. And maybe let's start there. What does it mean, the circular economy for batteries?
Yeah, definitely a great question to ground us here. The circular economy in general is about not creating waste. So, being thoughtful and having a plan and strategy for how do you handle products at end of life. So, obviously, I think most people are very familiar with recycling and, how you can do that personally. But another part of that, which we're trying to promote more of, is reuse. So what that means for an electric vehicle battery is, let's say you have a Tesla and, has, I think, at the beginning of life, 270-mile range. And at some point, the battery will degrade, and you will see that through loss of range over time. It takes you longer to get to a charge. And at a certain point, it might not be good enough for a mobility application. So instead of just taking that to recycling, you basically find a new application for that in a less stressful environment, which would be ideal. So oftentimes that is a stationary application because the load is somewhat more predictable and less stressful. Because if you imagine, revving up your car to get on the freeway, or carrying a big load, let's say you're going on a road trip and you have a lot of stuff in the car, then you can end up really stressing out the battery. And on top of that, in some cases, if you're doing all those activities in an extremely hot or cold environment, that does also cause the battery to degrade faster. So in a stationary application, maybe you can put it in a box and somewhat control the temperature a little better. And, maybe it's to help you just keep the lights on. Maybe the most stressful thing it's doing is running the AC. So those are applications where the stress level isn't as high on the battery, and it can actually have another 5 to 10 years. I've read some papers where people are projecting that it could be another 20 years, depending on the end application.
Amazing. I love the idea of reuse for sure. And it's funny because I mainly work with stationary batteries, only working with like mobility batteries through like the charging applications, because charging is part of the stationary system, right? And so it's all really fascinating. So tell me about what that looks like. So I think what ReJoule does, tell me a little bit more about the ReJoule process. It's about testing, right?
Yes, our focus is on the diagnostic side. That's really where Stephen, my technical co-founder, his specialty, he has a master's in electrical engineering with the focus in power electronics. So what he came across was the ability to scale up a well-known lab characterization technique called electrochemical impedance spectroscopy. We don't say that mouthful every time we call it EIS, which is what most of the industry calls it. And what we've been able to do is created a piece of hardware that connects to the battery and performs this EIS measurement. And then our software does some data processing to create an aging algorithm. And all this can happen within seconds to minutes and is also non-invasive. So when we do the test on the battery, it doesn't affect its longer term state of health. Where that's different than some of the standards done in the industry today is if you were to try to measure the battery's true health, one thing you would do is to charge it up fully to 100% and then measure how long it takes to drain it. There's a lot more science and detail behind that. And for those that are curious, we do have a case study that talks about that on our website. But at a high level, that's really what you're doing. And that requires specialized equipment. The equipment we have costs tens of thousands of dollars. And you also need specialized labor, people that know how to handle batteries and that know how to program that equipment.
Awesome. And so who do you see as the user of the technology? Is it like an individual electric vehicle owner who says, yeah, I've noticed my battery degradation, and I need to bring it in somewhere to get it tested? Is that the beginning of the flow?
I would say that maybe like in the very far future, maybe when electric vehicles have reached like pretty much 100% or reach mass penetration, that might be a point. But at this stage, it might make more sense for it to be owned by a service center, so maybe the dealership. And in the case for repurposing batteries, it can come down to who owns that battery at end of life. So in China and Europe, for instance, there's legislation or regulation that basically says that the automaker is responsible for disposal at end of life, in which case we might be selling to them or whoever is a third party they might have brought on to help them manage these assets or liabilities, if you will, that the batteries may be to them. So that's where we are looking right now, is to companies that are helping the automakers with managing batteries at end of life that do remanufacturing, repair, repurposing, and recycling.
I've never thought about that before, like who actually owns the battery and the responsibility for it at the end of life. I know that, we work a lot with like solar plus storage. And so I know that it's a big deal also for solar, who's responsible for the deposition of, panels at end of life and, racking, and is that an extra cost or, all of this other, how does that get worked out in contracting? But I hadn't thought about it from the vehicle perspective too. So I'm curious also, on the stationary side, like I personally see a huge opportunity there for testing and possibly decommissioning and then possibly reusing stationary batteries as well. Have you guys considered that?
Yeah, definitely. It was a toss-up for us between which industry to focus on, and we decided to focus more on electric vehicles because, electric vehicles and energy storage is growing at a very rapid clip. And I think it's been accelerating, interestingly enough, since the pandemic has begun.
Well, I would say that electric vehicles are driving the expansion of energy storage, right?
No pun intended, right?
Right. Oh gosh, I didn't even know I did that. Oh my God.
Yeah, so we definitely we see us sitting at a bit of the intersection. Earlier in the introduction, you mentioned that we have a grant to fund us repurposing used EV batteries into a stationary application. So a big part of what that grant for us is not only testing the batteries, but also understanding all the technical challenges, as well as just other challenges, such as like thinking through permitting and regulations and standards, because this isn't something that is been well established.
For sure.
Yeah. And like, even though there are projects all over the world, it doesn't matter if you're doing a project in LA County and they've never seen one before. So how do you go about approaching all of that? So those are all challenges that, we will be tackling, and we'll continue to talk about those challenges, through platforms like PowerFlow with you, Amy, and also through our blog, as we find that, there's a lot more that needs to be established. And, that's our way of letting people know that these are problems that need to be addressed, so that hopefully more startups or corporates help in that process. And also just so that when people want to set out on these projects too, what are things that they want to keep in mind so that it doesn't become like prohibitively expensive or things just fall apart. Like, we want to encourage repurposing as much as possible, and for all of us to learn together.
Oh, definitely. You had just said that often it's the manufacturer has a responsibility for the battery of end of life. Because I was curious, then what happened? Like, then what? So, they're using the ReJoule testing technology to establish when the battery is no longer appropriate for mobile application, it can be reused. Then what happens? Like, who takes charge of that battery? So that's the manufacturer, and presumably they have, or the auto dealership or whoever. And now it's their responsibility to find some outlet for the battery to be reused, or some resale market. What's the vision for that?
Yeah. Right now, there is no established market, and we're finding that in cases where they have small quantities, some of them are being sold on eBay, and which, I guess it's good if there are people that are doing some battery projects and learning more. But then there is the big question of, just like the customers that ask you what happens to this battery at end of life. Like, there's a big question, like, if you have a DIY project, what are you going to do at end of life? Because you probably don't have a relationship with a established recycler. And
you bought your battery on eBay.
Yeah. Like, eBay's not going to help you with that necessarily. I mean, maybe in the future they will. So one of the companies that we actually work with, they're called Renewable. And they're actually trying to create that marketplace for the used EV batteries, and to ensure that it is going to be responsibly disposed of at end of life. And that's a really big undertaking. So we're excited to partner with them. They have recycling partners that they've identified as well. And just to also cover, like, not only the recycling, but also decommissioning and shipping the batteries. Like, these are physical products that are big and heavy, and they need to be safely handled by people that are trained. So it's not just like, like, you don't just call like take my junk or something and just put it on the side of the road and just someone puts it in a truck. Like, it's not that easy.
Yeah, absolutely. I think there's a general kind of attitude out there, and I don't know if it's just a human tendency, that we don't like to think about these things. Like, we don't like to think about what happens, at the end. We don't like to think about disposal of anything, really, and maybe that's why it's so tough to, like, get widespread, commitment to recycling. And even individuals who do recycle, I'm talking about recycling in general, like plastic recycling, that, like, we're not even sure that all of that plastic does get recycled, when it gets sent off. And it's something that I think is hard for people to think about, especially when you're in that fresh energy of, again, no pun intended, that fresh energy of like a new project and like, yeah, we're going to do this cool like EV project or this cool solar plus storage.
Yeah.
And thinking about the end and what you're going to do is kind of a hard thing to see up front. And in a lot of ways, like what we end up telling people is like, we'll figure it out when we get there. Like we just don't know. There just aren't that many battery storage projects that are 10 or 15 or 20 years old. And so we're going to assume that for better or worse, that in 10 or 20 years, we'll know what we should do.
Yeah. And I think that's a big part of the challenge too, because, obviously if you have a project that's just 1 year out, then it makes sense to think about how to decommission it in 1 year. Obviously that those projects don't exist because it costs probably a lot just to get it set up. But especially when you're talking about 10 to 20 years out, like you just don't even know what companies will be around. You don't know what technology will be available. So that is, I don't think that is just about like not wanting to think about it. I think that it's just, you don't know what's going to be available. And so like you have to a certain extent, just kind of keep that in mind, or like almost set a reminder for maybe in 5 years, just start doing some more research or something like that. But I think in some cases, though, I have heard some stories where people did realize that they should have done that earlier. And I'll give just some quick examples. These are just stories I heard secondhand from other people where, especially if you have a project on an island or in a remote area, you need to actually start thinking about those things much sooner. Because if, let's say, your equipment arrives or there's some damage to the batteries that you have, what are you going to do then? Because if they're sitting there and they need to be sent off to be recycled or inspected, and you didn't have a strategy for that, then you just have these batteries sitting there that probably take up a lot of space that you might need, and you don't have a resource for it. And it can be very, very expensive to try to do that last minute.
That's really good. Food for thought, points of information. I love it. So I wanted to ask a little bit about you personally. We've been talking a lot about what ReJoule does and like the technology, which is really awesome and I think very important in the industry. So tell me a little bit more about yourself. You spent a lot of time in corporate, some big corporate, and you made the transition. You made a transition of industry from more kind of consumer products to the energy industry and into, foundership, into an entrepreneurial venture. So tell me about that transition.
Yeah, it was definitely a big change. And I would joke because I went from working at Walmart, which is, one of the most well-known brands in the world, and companies and biggest companies, right? Like they have been Fortune 1 for a while, to literally the smallest company I could find, because it was my brother that called me and said that he had an idea, and I started helping him on it. I think like part of me, like I've always wanted to try my own venture. Our parents, they own their own business. And actually a lot of our family, they run their own businesses. So we've seen the hard work that it takes, but also the flexibility to a certain extent that it affords when, they reach a level where things are running smoothly. Obviously for a startup that is not the definition of a startup.
No.
But at the same time, our family knows what it takes, and they've been very, very supportive. In terms of transitioning to a different industry, like when I joined Clorox, I knew nothing about manufacturing. I mean, I used cleaning products, but I did not know how to market them or do manufacturing. And I supported the marketing business units and the manufacturing business units and learned a lot. And I loved it. When I joined Walmart, I didn't know anything about e-commerce, especially when I joined back in 2008. It was still a pretty nascent industry. And I bought things, but I didn't really buy things online. But like transitioning to energy though was a pretty stark change, because yes, we all use and consume energy, and we drive cars, but like knowing how those industries worked, or sometimes didn't work, is definitely a big learning. So I would say that I spent probably the first 6 months just attending as many webinars as I could, reading up on different papers. My husband would come home from work and he would see me like reading like scientific reports and like over and over again. He's like, what are you doing? Yeah, I mean, I still struggle with those, but like, you know, as much as I can absorb, I do. And we definitely started meeting the right people where they pointed us in the right direction for me to continue to stay on top of the information, and also advisors too, that kind of help you interpret all the information that you're getting. But I think the most exciting thing for me though is just like when I joined Walmart in 2008, and e-commerce was just starting to really grow, and Walmart was starting to put a lot of, money and effort into it. Right now, the energy industry and the automotive industry is going through a major change. And it's really exciting to see, you know, some things that have been around for like hundreds of years now doing a complete overhaul. And, you know, large corporates are, you know, trying to figure out what to do with all the resources that they have. And, you know, oftentimes they're looking at like innovators like ReJoule to figure out like, what's that new place? What's that new future look like?
Yeah, totally. What jumped out at me from that was, from your experience, was the thing that, you know, you're a consumer of energy, but like had kind of no idea. And I feel like that's the case for like a wide swath. I think that energy as an industry is kind of like the most like technical and like engineering thing that direct consumers interact with and have absolutely zero understanding of.
Yeah.
You know,
totally.
to most people, like, you know, you pay your electric bill, you probably don't look at it. You don't know the difference between a kilowatt hour and a kilowatt, which is totally fine. Like most people don't, right? And like, you know, the power comes on when you put the light switch. Like that's, I mean, even cars, even like, you know, internal combustion engine cars, I think most people can look at it and say like, yeah, like I know that's the engine and I know the basic parts of it. Even if I don't work on cars, you know, I know the basics of how this works. And so it's really, it's a really interesting thing. But I also have found, cause you know, I myself came into this industry from a different one. I was in aerospace, and I found that picking it up has been, you know, a pretty easy experience. Like there's a lot of information out there to consume, and you can kind of come up to speed on like the major issues, you know, pretty quickly. There's a lot of resource out there.
There is. I think the hard part sometimes is, like not rat holing yourself into like something completely random, because it's just so fascinating once you like, it's almost like peeking behind the curtain, because like as a consumer of energy, like I just didn't really understand how all this works. And it's not like they try to hide it. It's just like you said, I think there's a lot of technical elements to it that people don't understand, or they maybe choose not to, you know? And so once you're exposed to it though, it's really fascinating.
I think in some ways that they, you know, whoever they is, the industry, like sort of did try to hide it, not in a malicious way or like a you don't get to see it way, but for so long, like, you know, electricity has been like, you know, they want people to feel very stable about it. They want it to feel ultimately reliable. And, you know, they take, you know, traditionally the way the market financial models have worked, you know, the utility takes on all of the risk, all of the financial risk. They absorb the risk of the wholesale market spot prices. They had absorbed the risk of the, you know, spikes of demand and trying to, you know, operate peakers to meet demand at, you know, almost any cost, you know, to keep the lights on.
Yeah.
And I think there's been this cultural acceptance that like, it's okay that we don't know how that works. Someone else is taking care of it. And what we're seeing with this like revolution of clean energy, of electric vehicles, of like people saying, no, I really like to take responsibility for my own consumption. I think we're seeing a big transition of like, wait a second, you guys want to know about that? Like you want to know what the risks are? So I think it's part of the tidal wave.
Yeah. Yeah. And, I think what's interesting too is there's another company, startup that we've talked to before, and their focus is on, helping companies, or not companies, but like consumers, in the event of a power outage. And they said that, they had a hard time at first because like power outages happen all the time, but people just, for some reason, just don't remember them. And like, it's almost like a blackout in your brain too.
Yeah. Block it right out. Yeah.
Yeah. And sometimes if it's short, obviously, like if it's just a split second or like, maybe even an hour, maybe like you're like, okay, I'm just going to read or take a walk. Right. But I actually got a message from, so we're doing a deployment at 2 different sites. And I was talking to the tenants for one of the sites, and she said like, hey, we actually had a blackout in our area for 7 hours. For some reason, we weren't impacted, but we opened it up to our community. So she's like, yeah, you're definitely on the right track in terms of helping us deploy this battery storage, because like, can you imagine like a 7-hour blackout? And like, this was just like this week. So this is like the middle of summer in LA, like being like maybe without AC, like, it can be unbearable. So I'm sure that one might be more memorable.
Yeah. Yeah. Well, that's a really great place to take a break here, and we're going to be transitioning here to talk about, the new clean energy economy. So we'll do that after we come back. Here on the Power Flow podcast today, we're talking to Zora Chung of ReJoule, battery diagnostics, optimization, looking at enabling the circular economy for batteries. But here we're going to start to, turn toward the future. And Zora, from your perspective, personally, not necessarily like ReJoule, the company, but now that you're here in the energy industry, you're working to, help reverse climate change, enable more renewable forms of energy. What do you think is the biggest challenge or roadblock standing between us today and this new clean energy economy or the all electric future?
Oh, that's a big question. I guess I'm most familiar with the adoption of electric vehicles because that's really the market that we're focused on. And so I think like that hasn't changed too much. The charging infrastructure and also consumer comfort with this new technology are things that I see as a big change that's needed. The way that we're trying to address that is by providing more education on what batteries do, how safe they can be, and just in general, what tools we can provide so that people understand the health of the battery, because I think in a lot of cases, it's seen as a black box. So I've talked to people where, their adoption of electric vehicles, like they're considering. So one challenge might be like if you, like me, you live in an apartment, so you can't just set up your own charger, for instance. So you need to figure out like, okay, how am I going to be able to charge my car when I need it? It doesn't need to be every day. So if maybe there's a charging station within walking distance or not too far from my home, maybe that's okay. But am I willing to even put in the effort to do that? Because sometimes, any type of change is just too much work for people to think about. And I think the other one is just setting up charging infrastructure itself, where it takes a lot of work. You need the utility to go out there and provide that level of power. I was listening to another podcast about what's that effect on commercial vehicles. So if you think about something like long haul trucking, right? Like think of that as like 5 vehicles in one, and the amount of charging infrastructure required to do that throughout, like even the continental US. Like that's a lot of power that you need. And I think we really need a lot of other solutions. And perhaps it's, using repurposed batteries to power that as a complement to the grid. So I think it's just a lot of education for people that might not have access to it. And I think that's really important. I think there's a lot of ways that we can try to address that. One thing that we're trying to figure out too is, how do we create more jobs into that space and get people more exposure to that? And one way we're looking to do that is creating our diagnostic tool and making it easy so that someone with just like some high school education and some basic training can start to do that. And that way you can also have more people doing repairs for electric vehicles, because that's another concern that you will eventually have is not only how do I charge it, but how do I know that I can get a repair for it? Like in Southern California, where, there's actually a decent amount of electric vehicles, you might have more people with that expertise. But what if you're like in the middle of a place where there aren't that many electric vehicles sold? Like, how do you know that there was someone that can service it? And if there isn't, like, what if it takes like weeks to maybe even months, right? If there's a real issue, and those don't happen often, but that could be a real concern, because then how do you get around?
I think the point about the workforce, creating workforce, creating green jobs, I love talking about that particular issue because it addresses multiple needs at once, right? It addresses the need of the technology, like you're saying, that like eventually, we need maintenance, we need infrastructure, we need maintenance on the infrastructure, like all of those. And I spoke to Camille Terry, who's the founder of Charger Help, mm-hmm. and that's what she's focused on is maintenance for charging stations, right? Mm-hmm. And so then now you're talking about like also maintenance for electric vehicles, and so at the same time that you're helping, the proliferation of electric vehicles and clean energy, you're also creating jobs, and so mm-hmm. it's like very specifically and explicitly helping people, mm-hmm. humans, and the economy in that way, and in supporting families. And so I love that like cross-sectionality, that like, yes, we can save the planet and we can also be supportive of humans in the economy at the same time.
Yeah, definitely. And I love what Camille and Charger Help is doing too, because I think their focus is like, we're not talking about jobs that are like corporate jobs where you just sit in front of a computer, right? Like when you're talking about maintenance, you need people that can work with their hands. And like these can be people that are currently doing repairs for your combustion engine. And as the economy shifts to electric vehicles, let's hope that the same people can also work on your battery electric vehicle.
Exactly. And I think creating the knowledge base, culturally creating the knowledge base, eliminate some of that fear that you were talking about, the mm-hmm. fear of change. Yeah. That like if we feel comfortable that as a society we have a comfort level with how to work on things and how to make them work, mm-hmm. That eliminates some of that fear. So amazing. So from your perspective, there's the important things we can do as an industry to solve, these challenges, these roadblocks. You already talked about, consumer education and helping like alleviate some of that fear of change. You've talked about like infrastructure and the workforce that needs to come along with it. So something else you mentioned to me was standards. Standardization, information sharing around standards. So mm-hmm. tell me about that. Tell me, what's the vision?
Yeah, our vision is to set a new standard in battery diagnostics. Just for those who aren't aware, right now for batteries, you can measure voltage, current, and temperature, obviously over time. And the way to think about that is these are quite crude measurements, if you will. So if you were to, let's make an analogy to like the human body, for instance, it would be like the doctor getting just like your heartbeat and your temperature, and sometimes maybe even just with their hands, right? So not even being able to track that very well, like that's that's how we equate the state of battery data today. The more data you have, the more sophisticated of tools you have available. But without more advanced technology, you're just basically trying to get more out of that crude data. And that's just not really scalable if we want everything to electrify. And in a lot of cases, electrification is happening through batteries. So that's why Stephen really set out.
Totally.
Because it's like, this data is not good enough. And the more better data that we can get, the better the models we can create to actually understand what's happening inside the battery. So like, we need to open up that black box and understand it. And one way we need to do that is through standards, because if everybody's speaking a different language, opening up that black box is more like a Pandora's box, because if you're looking at a Hyundai vehicle versus a Tesla, versus like what you may be working with, Amy, like stationary storage, and everybody uses the same metrics, but you actually measure it differently, and your benchmarks are different, then we're no better. Then it's just even more confusing. And then people have to start making their own assumptions. So we need to have some standardization in terms of what is shared, and how it's measured. I'll give just another brief example. When I was trying to learn about all the different metrics in the industry, and a common term is the state of health of the battery. And that's usually represented as a percentage of the original state. So if you're at 97% state of health, you lost 3%. For those who have cell phones and you have the battery indicator, that's probably your closest reference to it. But then I learned that each company defined it differently. And sometimes even within business units, they defined it differently and measured it differently. So while this is a very common term across the industry, you don't actually know what people mean when they do it. So oftentimes people perform their own testing based on their own measurement. And that's just, to me, that's a little bit of a waste.
Yeah. And not very useful. I love what you said about needing to open up the black box and understand it. And how do we understand it? We get more data, the right data, standardized data, no matter what kind of battery that you have. And then we build a model. And as a modeler, that's music to my ears. And I think that's also hard for people, lay people who, want to be part of the energy transition. And when we talk about electrifying everything, it can be hard because they can look at their internal combustion engine and see how it works. And everyone is sort of familiar,
right?
And you can put your hands on it. We also have here, we live a little bit out in the foothills west of Denver. And so in addition to our vehicles, we have a 1960 Fortson diesel tractor. And we use it to regrade the driveway and stuff like that. And in 1960, there ain't nothing electronic about that vehicle. Let me just say, it is you can go in there and I mean, I'm an aerospace engineer by training, but I love mechanical. I'm a person who likes to put my hands on things. And so with that vehicle, you can literally say oh yeah, this rod connects to this wheel over here, and then it moves this over here, and these are the hydraulics, and that's how it works. And there's no mystery to that. And so moving over to a system where the way that you see how it works is you look at the model.
Yeah.
That's a huge mental shift that we can trust the model to show us how it's working based on real data. I think that's a huge shift. And one I would like to see more comfort with.
Yeah. And we definitely don't want people putting their hands on the batteries either.
Yeah, please don't do that, actually. Well, awesome. And I definitely, I think industry-wide we're in this place of needing more and better standards. And it's tough, right? And for me as a person who digs innovation theory, you don't want to bring in standards too early because that stifles, innovation and development. But But at the same time, we're seeing that the similar things from like the behind the meter side. We do a lot of modeling around resilience. So if you've installed these assets, partly so you can save money on your utility bill, but also because if the grid goes down, you can stay up. You have resilient backup power. But how much? How long is it going to last? And, there's no standard way to talk about that in the industry. And everyone comes up with kind of their own little I kind of think about it this way. And, there's a lot of people trying to work toward value of resilience, like equating whatever that resilience performance is to some kind of dollar amount, which is a little more specific in its idea, but not any more specific in how it's calculated.
Yeah.
So I think that's an interesting bit of information, though, on how the key metrics are defined for batteries. We're kind of all in that same state. And I loved when we were talking earlier, you called it the wild, wild west. It's a little bit of the wild, wild west now. And we use that term around here all the time. So it's always funny and affirming to me that you can come from completely opposite sides of the industry and be like, yep, it's the same from my same view from my chair.
Yeah. Actually, I just remembered while you were talking about resiliency, one thing I wanted to add to that is as part of that $3 million grant to repurpose used EV batteries, one of the goals is to provide resiliency. And I'm not sure if you're aware, but it was actually 24-hour resiliency of critical loads. So here it's a bit more defined, and it's very interesting because 24 hours, that's very clear what that means. But critical load, that varies by person. We're working with commercial buildings. And so, one of the companies we're talking to, they actually do COVID-19 research. So their critical load is refrigeration. And they're like, we can shut everything else down, make people go home, but the refrigeration needs to stay there, which makes sense because these are samples that they might be working with, and you don't want to ruin all the research, right? And they even asked us, can you do 48 hours? And then we talked to, an artist studio, and their critical load is basically, we want the machinery that we have to keep running, like the CNC machine, if we can get that even just another 3 or 4 hours out of it so that the artist can finish their work. We don't need 24 hours, but we just need that machinery to stay on so that if something shuts down, they're not stuck in the middle of work and they have to start all over again. So I see those are some of the challenges that we have in the energy industry because everybody uses it differently. And so it's very hard to set standards. So I think it's a very interesting challenge that we're going to have to address.
I'm just gonna add to that a little bit and challenge you there. I loved how you said that the 24 hours is really clear, but the part that's not so clear is about the critical load. And I'm going to challenge you and say, actually, just saying 24 hours actually isn't clear because resilience durations, and I'm going to nerd out on my own area of expertise. Resilience durations are stochastic. They are probabilistic. They are highly dependent on what's going on at the time. And so that might be, and it's somewhat related to what that critical load is, but it's also related, it could be related to the season of the year because your company, their COVID research company that needs refrigeration as their critical load may have a heavier refrigeration load in the summer than they do in the winter. And if it's paired with, if the storage, whether that's a reused battery or a new battery, is paired with solar power, well, your solar resource is also affected by what time of year it is. And so we usually define those durations, and this is just food, little brain vitamins going forward to think about. We usually define a duration and then a confidence level. So I want to have 24 hours with 100% confidence. No kidding. No matter the time of year, time of day, if the power goes out, I need to stay up for 24 hours is different than, I'm willing to, I just want to be assured that 95% of the time I'm going to make it 24 hours. Mm-hmm. And if, I recognize that if there's a really big storm or something, that's a different case. Right. And that's way different than saying, yeah, as long as I can have it 24 hours, 75% of the time. Some people come in and say, like, I recognize that, like, because this is solar, I'm probably going to be more likely to have better resilience in the summer than the winter. And I'm willing to accept that to not have as expensive a system.
Right.
And so, like, that's the level of complexity that it's like, it's hard to explain because humans are really bad at statistical analysis, that like why it's about not just a fixed duration, and this is the last thing I'll say, because I could ramble on this for a long time. We just had this conversation here that humans like to think in binaries. It either works or it doesn't work. And, we're seeing that over and over, like with COVID, for example, with the pandemic, people are like, well, masks either work or they don't work. What are you talking about? Or vaccines, they either work or they don't work. So why are people still getting sick if they had the vaccine? And it's like, well, it works 70%.
Yes.
Which is a lot better than 0%.
Yes.
But it's still not 100%. And this is the same kind of thought. That like you're going to get your level of resilience for 75% of the time or 98% of the time, but maybe not 100. And that might be cool for you. Yeah. And so anyway, sorry we could, I can nerd out on that for a really long time, but yeah, but I think it really speaks to, like, again, it's a similar concept from a different angle of like, how do we define a standard when you have all of these complexities? And I think where we are as an industry is like just understanding the complexity.
Well, I was going to mess with you earlier, said people think in binary in terms of what works and what doesn't work. I was like, how do you define what works? Right. Like,
right.
Yeah. And the problem is I think people don't necessarily communicate what that exactly means for them. So then if you're working with someone else and you have different definitions of what it means for something to work, that can be another challenge too.
Oh, I love this conversation. This is the type of theoretical conversation I could have for hours and hours. But I think our time is about up here. So do you have any final summary thoughts to share?
Yeah, I think if I could take, I guess, one position just on climate change and just on especially if you're listening to this and you're like, what is electrochemical impedance spectroscopy? First of all, thank you for listening and trying to educate yourself. And I think the other thing is try to focus on the positive side because we already know the doom and gloom story and we know the things that we have to do. Whatever part you can play in helping with that, including educating yourself. It could be as simple as, contacting your representative so that your city, state, federal government starts thinking about these things, or even just, the way that I technically like to think that I got started into climate change was when Walmart shifted away from having trash cans at everybody's desk because a way to reduce waste in the office. And, people still had the recycle trash right next to them because we still had a lot of paper at that time. And we've moved a lot more digital by the time I left. And I remember there was one person sitting next to me that was basically peeling his orange into the recycling bin, and I scolded him. And at first, I think he was a little bit upset, but he knew that he was doing the wrong thing. And as soon as someone called him out, he never did it again. And he actually thanked me for that later. So, I think everybody has a role that they can play. And I've also converted my husband too, from just, throwing the recycling into the recycling bin to actually cleaning it out, which is what you should do. And, now I think he's actually telling other people to do that too. So, you can have an impact. And I think as long as you just kind of get that started, your impact will start to grow.
Yeah, lots of little baby steps, and we can all make a difference no matter where we're working.
Yes.
Well, thank you so much, Zora. It was a real pleasure to talk to you. Thank you for being on the show today.
Thank you for having me.
And thank you, listeners, for being with us. We appreciate and value your time. And thanks for joining us for this episode of Power Flow Podcast. We'll see you next time here at the whiteboard.
Thanks for joining us for another episode of the Power PowerFlow podcast. If you enjoyed the conversation, please share the episode with other innovators, leave us a positive review, and subscribe to PowerFlow on Apple Podcasts or wherever you listen to podcasts. You can find show notes for this episode, more great conversations, PowerFlow merchandise, and more at powerflowpodcast.com. PowerFlow is hosted by Amy Simpkins, produced by Devin Shonchuk, and managed by Laura Novak. See you next time here at the whiteboard.